Hello everyone, I welcome you all to the brand new episode of Anju Speaks Tech. In this new episode, we will try to do a deep dive that why does truncate work faster than delete in Postgres. Now before demo, let's try to discuss some of the theoretical points related to truncate. Truncate removes all data and it resets the table to its original empty state. It can also reset or restart the identity sequences if you truncate it with the parameter restart identity. Then truncate does not go for a table scanning, and truncate avoids row by row deletions. Truncate also requires an exclusive access exclusive log on the table on which truncate is being executed, and truncate is transaction safe. So if you roll back the truncate, you can safely roll it back. Okay, provided the transaction is not committed. And the last one is truncate is not MVCC safe. Now, if you ask me that why truncate works faster, so definitely you can pick up some points that it doesn't go for table scanning like delete, and it also avoids row by row deletion like the delete statement. But we are specifically interested in what's happened under the hood when you run the truncate statement in Postgres. So for that, we will quickly check a demo because it's better to learn by doing things. So I have logged into one of the sandboxes, and there I have installed the Postgres version 17, and there I have also created a test DB. Now let me quickly check the version. So the version is 17.6. And by the way, I have also taken another terminal of that same machine where I am at the path of the data directory of this database. Okay. So now first what I will try to do is I will create one sample table. So the sample table is created, and then I will try to insert some record. So now I have inserted 10 lakh records. So next what I will do is I shall try to run one command, a statement to fetch few details related to this table. So if I see that the object identifier of this table is 16440, that is basically the tablet object ID. This is the tablet name, that is sample records, and here this rel file node, it is 16440. So basically this is the actual data file which holds the data of the sample records. Now let me go to the other terminal and check the same. So here we will look for this rel file node 16440, and if you look at this, the last three files, that is 16440 it is. But you may ask that okay, 16440, the highlighted one is the actual data file, but what about this FSM and VM? So let me also share what these two files are. So the first thing is the main data file, that is only 16440. It stores the actual table rows in a sequence of pages or blocks. Now the file that has a suffix of FSM. FSM stands for free space map. Now, this file keeps track of the amount of available free space on each page of that main data file. So, for example, say when you try to insert a new row, and then Postgres quickly consult this file. It doesn't go and check the main data file. It quickly checks this file only to find out that whether a page has enough space to accommodate that new row to be inserted or not. And also, it helps to optimize the write operations and reduce fragmentation. Now, the other one, that is the suffix VM file. So VM stands for visibility map. This file helps Postgres to optimize vacuum operations and select queries. So this shows that the visibility map shows that okay, the pages in the main data file that are all visible, meaning those rows on the page are visible to all current and future transactions. So it also avoids unnecessary checks for row visibility, especially while you are doing some index only scans. So that is for these three files. Now, first, what I will try to do is I shall try to delete the record of this sample records table using delete statement. Sorry, okay, delete from sample records. So here we see that it takes around 984 millisecond. Now, if I check the count is 0. But if I run this select OID rel file node related query once again against that same table, I will find that there is no change. So the OID is 16440. Even the file node, rel file node is 16440. There is no change. Now let me go to the other terminal and check the file location. 16440. So here you can find that 16440, 16440 VM and 16440 FSM all still are available. So we have deleted the record from the table, but still we haven't performed any vacuum. So vacuum sample. So I have done the vacuuming. So here you can see that after this vacuuming, so the Postgres has regained this disk space. So now the main data file, earlier it was 362490, those many bytes. But now if you see the main data file, it has gone to 0 bytes. Now next, let's come back to the previous terminal. And here again, what I will do is I will insert those 10 lakh records. So again, I have inserted 10 lakh records. I have switched to the other terminal. So here you can see that again this main data file, it has occupied 35 MB, and we have these three files: that main data file, the FSM, and VM files. Now this time I will try to erase the data from that sample records, but this time using truncate statement. Let's try that out. So now I have truncated the table, and you can see that it only takes 15 milliseconds. But when we executed the delete, it took 984 milliseconds. It's way much faster than delete. Now if I go to, okay, let me run this select OID statement once again. Now here you will find that though the object identifier, that is still same, that is 16440, that points to the same table, that is sample records, but here under this rail file node we see a change. Now it has been changed to 16444, but earlier it was 16440. And if you see, now we don't have anything in 16440, we have 16444. Now that is basically what happens under the hood. Now once you truncate the table, it basically deletes the older data, and obviously it makes it the older rail file that we have. So it makes it empty, and it creates a new file, and then it points the table to the new file only. Now if I insert those 10 lakh records once again, so now we will have this 16444, the main data file. Then now the two files, that is FSM and VM, these two are also created. So in a nutshell, whenever you truncate, basically Postgres discards the old link with the old rail file node, that is the file where it kept the data, and then as a part of truncate it creates a new rail file and then points that table to the new data file. So that way it works this fast. Now let me conclude this video with another feature of truncate, that is the point number 2 that we discussed, that truncate restarts identity sequences if you have used restart identity parameter. Let's try to check that as well. So first what we will do is, I'm checking if we have any sequences available or not, and then I see that yes, we have one sequence that is on the sample record table. So if you see the sequence number, that column is basically a serial one. So that's why it has automatically created a sequence of its own. And that is what we can see under select start from PG sequences as well. Now here I would like to ask you to pay attention with the start value and the last value. So the last value now it is at 30 lakh. If you ask me that why it is 30 lakh, it's just because we have inserted, then deleted, then truncated, again inserted, again truncated, all this we have performed these activities in last few steps. So that's why the last value of this sequence has gone up to 30 lakh. Now this time what I will do is I will truncate the data once again, but with this restart identity parameter, and then I shall come and check once again this last value, check that whether it gets changed or not. Okay, let's do that as well. Count one from sample records. So now you see that we have 10 lakh records here. So this time again I will perform a truncate on the sample records, but with this parameter restart identity. Again table has been truncated. Now again if we just check the select OID rel file node statement, this time again you will have a new rel file ID, that is 16445. Earlier it was 16444. Now the other thing is, if I do a select star from PG sequences, we will see that earlier this value was 3 lakh, but after truncating with this parameter, that is restart identity, now this last value has been reset. So that is what it says, that truncate restarts identity sequences if we use restart identity parameter. So that's all for this episode. Stay tuned for uh, more such topics to be covered in the upcoming videos. If you have liked the video, please do hit the like button, share with your peers, and just do subscribe so that you will get all the updates of the upcoming videos. Thank you. Stay tuned.